we're gonna have a look at my plane today, and we're really gonna focus on this pan tilt setup that I have here. It's my own design, something that I created, and I'm pretty proud of it. I like it, and it does 270 degrees, you know what I mean, around on the pan, and about 70 degrees down on the tilt, which is enough because if you go any more, you would see the edge of the plane. So we're going to take a look at that in a few minutes. First, I just want to do a quick overview on the rest of the plane and just show you the rest of the setup real quick, so that you know, this is my second build. This is my second mini Talon build, and I learned some things from the first build that I want to share with you, and then we'll take a close look at this pan tilt system, and I'll tell you where to get the parts. And there's a little bit of the servo that I use in here is a 270 degree servo, but if you buy it and just plug it in and go to use it, you're only going to get like 130 degrees out of it. There's something you have to do in iNav or whatever system you're using to get it the full 270 degrees, and we'll talk about that in a few minutes. First, let's take a look at the rest of the plane. So this is my second mini Talon build. I'm running on R9. I've got the R9 over here in the wing and 5.8 video over here in this wing. So yeah, here's my R9 setup. You can see it on both sides there. Yeah, I've got the antenna sticking out the top and the bottom here, and that's working really well. My last mini Talon, I wanted to keep the wings removable, because I had the idea that I was going to remove the wings. It turns out I didn't have it for that long before I destroyed it, but it turns out I never took the wings off. It fits on my car with the wings on, so this time I decided just leave the wings on. So the wings on this machine are permanently attached. I've got them taped on just to cover the seam here, and they're also glued on, and the clamps are tight, you know, and I periodically check the clamps. So I had no problem putting gear out this time. Last time I built the mini Talon, I put all the gear in the center body, which is not ideal for radio signals. This time, I spread it out. So we've got control over here, video over here, we've got our satellite, our GPS up here, all our noisy stuff, our ESC and motor at the back, and the pan tilt camera up here in the front. So this is an iNav build, and we're running an F405 in here. I'll take a look in there. There's an F405 flight controller in there. Running iNav, that's the latest iNav, 2.2, something like that. And I run a 5,000 milliamp battery. It's up here in the front, pretty much all the way up at the nose. And that balances out this plane very nice with the pan tilt system. Without the pan tilt, it probably wouldn't balance. And the servo I'm using is a heavy servo, but I do need it, mainly because we got our ESC all the way at the back here. So our ESC is all the way in the back, and last time I built a mini Talon, I had the ESC on the inside, which wasn't ideal because there's not a lot of airflow in the body, and the ESC was getting hot. Even though it's a 60 amp ESC, and that motor combo never draws more than 40 amps, it was still getting warm. Not hot, but too warm for my taste. So this time I mounted it right up here on the tail, and that's working out. That's working out really well. So everything else is pretty standard. I just got a little paint on here. I've laminated it. We've got skids on the bottom, the 3D printed skids. All my 3D printed parts are PETG. PETG printed at 100% is unbelievably strong. This whole gimbal here is PETG at 100%. The whole box on the inside there is PETG at 100%. All my skids are PETG at 100%. And this, my Nakaduct there is PETG at 100%. I'll put in a clip of the video right here of me trying to break, back when I was designing parts for the pan tilt. I had a top plate that, you know, wasn't correct, and I tried to break it, and I put that video on Instagram. And I'll insert that video right here so you guys can see the kind of strength of the parts we're talking about. I really like PETG, but of course you could print these parts in ABS or PLA and they would be fine. The only other modifications I really made to this airframe are I used the original hardware here. So what you're supposed to do is there's supposed to be a board down under here, and this is supposed to go through the top, through this right here, and screw in, which is ridiculous, you know, on both sides. They get the same in the back. So what I did was I moved that piece of wood forward, put the screw through, and attached this servo horn in the front and the back, so that when you put the lid on, you can then just turn these servo horns, and that's secure. That's not coming off in flight, you know, for any reason. So that's working out well. These pieces right here are actually from an old quadcopter frame, from like an old ZMR 250, and they're the landing gear, and they work perfectly as pull tabs. On my last build, this hatch ended up breaking right here, right across where the spar goes right here, because just from pulling it up. So I put the tabs on there to stop that from happening. And I also reinforced around the NACA duct there with some carbon fiber to make that weak point a little less weak. So that's pretty much all for the airframe. I mean, I'm using a 60 amp Skywalker ESC. We've got a 2216 Sunny Sky motor in the back. Oh, I did put 3D print though on PETG also a motor mount, and see if I can get in there. You can see it. Yeah, there it is. Because that allows a little more airflow. It sets the motor off of the mount a bit and allows some airflow, so keep that motor cool. But that's a 2216 1250 with an 8x6 prop. This is my favorite combo for this machine's efficient and fast and powerful, and I like it a lot, and lightweight. I may try different combos in the future, but for now I really like this one. You know, a lot of guys want to go to bigger motor, but I don't see any need. Also, what's great with the 8-inch prop is it's higher than the skid, just barely, but with an 8-inch prop, the skid prevents it from hitting the ground, and that's a good thing. And also hitting your hand when you're launching. So you go any bigger to a 9-10-inch prop, yeah, you might get a little more efficiency, but you're not gonna be able to do that. The servos in here are just Emax ES08MA analog servos. You know, cheap servos. Same as this one up here on the tilt of the pan tilt. So I guess let's go ahead and get into the pan tilt now. So there's an ES08MA2 analog. That's what I'm using all over the machine, with the exception of the pan servo. Okay, so let's take a look at this here. When you print this out, this comes in 3 pieces. You'll have this front piece right here, this top piece, and this bottom piece. And you need a little bit of hardware to put it together. To secure the camera in and to secure the board down to the bottom piece, the hardware that comes with the Runcam Split Mini 2, which is what this is, will do all that. But you do need some standoffs. Now, I didn't put this in printed stuff. I let you just choose plastic standoffs so that you can adjust the height of the top of this. Because if you've got a original Runcam Split Mini, the 2-board setup, you can make this a little higher and it'll work fine. You know, I don't see any reason why a Cat external wouldn't fit into here. As far as I can tell, it definitely should. You know, it's got the same camera sizing, it's got the same board sizing. I haven't tried it, but I assume it would work. So you've got your tilt like that. That's about the maximum tilt right there. And then it pans 270, so you get, you know, from about there all the way around to about there. And it works really well, and I really like it. I'll have some video playing, I'm sure, in the corner here of the pan tilt going around, so you can see the kind of range that you get. 270 really is enough. I don't think you need 360, because with 270, I can see both of the tail fins of the aircraft from either side of the pan tilt, so I can see the entire aircraft all the way around. So 360 degrees to me is a bit of overkill. Okay, so the servo. Now, the servo I'm using, I'll put a link to it in the description, but I have a spare one here. Somewhere here it is. This is the spare one is the 180 version. But it is a big chunk of servo. It is heavy. It feels, I would say, yeah, I would say it weighs at least as much as this Runcam 5, maybe a little more. It's a Metal Gear servo. It's a cheap servo. I got it for $17 delivered on Amazon Prime. So 2-day delivery, $17, and there you go. But there is a problem with this servo, and the problem is if you just plug it in and don't do anything else and try to pan the thing, you're not going to get the full range of these servos. These are not like RC servos. I'll give you the number here. It's LD20MG. This is the 180 version. The one I have in there is the 270 version. I will link it in the description. But the problem is that RC receivers, RC radios, and iNav all run on a PWM width of 1,000 to 2,000. And this servo is designed more for robotics, I suppose, to work with an APM or a Arduino. So it needs a pulse width of 500 to 2,500. So to make this work correctly, you have to go into iNav or your radio, if you're not using iNav, or your ArduPilot system, and change the pulse width on only the channel you have this servo on. You don't want to change them all. You go into the servos tab of iNav and find the channel that you have this pan servo on and change it from 1,000 to 2,000 and make it 500 to 2,500, and then this will work. Although you will get the full range out of these servos. As I said, this is a heavy servo. It does weigh quite a bit. I needed nose weight in this build anyway, so I didn't really mind because, as you can see, I've got my ESC all the way at the back. So I actually, even on top of putting this pan tilt and this servo in, I still needed a little bit of lead up here in the front. But it is heavy. It is solid. It feels bomb-proof to me. The shaft is, I mean, you're just not going to break it. I would say the only thing that you're going to break, possibly, might be the thing that connects this to the pan tilt. So I use the 4-bladed one. It actually does come with a metal servo arm. I think this is the kind of servo you would use like on a like 1/8 RC car or something like that, to a steering servo. But it did come with that, but I didn't use that. I used the plastic ones. So I used this one, and I'd say this would be the weakest point between the PETG being tough, which you saw the video of me trying to destroy that, and this servo being rock solid. I would say this piece of nylon here probably might be the weak point, but still, I don't anticipate breaking this. If I'm breaking this servo and I'm breaking this pan tilt setup, I have done massive damage to the plane. It is not going to be a weak point. It is not going to fail anytime soon. So I have a link in the description for this servo, but don't forget that you need to change it from the PWM width to 500 to 2,500 to get the full range. Don't come back here and comment, I bought the servo you linked and it doesn't work, because I'm telling you, 2,500, 500, 2,500 will give you the full range. And I'll have the link to my thingiverse account so you can download this pan tilt setup. I like the PETG. If you try it in ABS, let me know. If you try it in PLA, let me know how it works out for you. But there you go. I'd like to see this on some other planes. So if you've been looking to put a Runcam split 2 pan and tilt on your plane, you know what I mean? In fact, you know what? Let's just fire it up and I'll show you the range of motion that we get out of this. Let me just get my radio. Okay, got my radio here. Move this back.
Throttle warning. Engine disabled. Middle rates.
Go up to my mini Talon.
Engines disarmed. Angle
Let it go
mode
through
off,
all the
off.
switch
Camera
positions.
centered. Camera on.
I put on the voice for all the switch positions just so I can remember what the heck all the switches do when I move them, so I know when
Return to
I
launch.
know when I move
Engines disarmed.
a
Acro
switch
mode.
where my
Angle
modes are
mode.
going to be. Anyway, so let's have a look at this. There we go. Got my lens cap on, but that's not really important. So I've got a lock
Camera
switch
centered.
here
Camera
that
manual. Camera centered.
when I throw the camera centered position will automatically center the camera. But
Camera
let's
manual.
unlock that and I'll show you. So we've got that kind of looking backwards. Let me pull my camera up there. And it goes all the way around to that far. So as you can see, you can, like I said, at both ends, you can see both tail fins between the wide angle lens and the movement of the servo. So there we go. And for down movement, we've got that's the maximum down right there, which is I don't use down a lot. I use pan a lot more. But if you went any further, you would see the edge of this. So I kind of had that in mind when I was designing it. I could have moved this down further, created a more of a, you got it to 90 degrees, but I don't like it to hang off the front, and I rarely ever use down anyway, so that's enough down for me. But that shows you the full range of motion there all the way through. And it's a nice servo movement too. It's pretty smooth. Like, even so, I'm just go full tilt around. It moves pretty smooth. It's not bad. Smoother than this Emax Servo, really. But what are you gonna do? And then we'll go back to camera lock. So there you go. All right. So I hope you enjoyed this video. I hope you can use this on your planes in the future. And if you have any questions, drop them in the comments here, or message me, or find me on Facebook, and I'll answer it for you. All right, have a good day. Bye-bye.